So yeah, I'm here to talk about Node.js and AI, and I want to talk about something that just happened to me. So this is my first time in Ireland, and of course, it's also my first time here in Waterford. And I got accepted, and I saw what it was like. Okay, a castle, right? Amazing. But then, how do I get to the castle, right? And then I start looking, and I go to Google Maps. Okay, it's like 3 hours away from Dublin. Like, okay, how do I get there? And then I could go by train, I could go taking a bus, or rent a car. And I didn't plan really good how I was gonna get here, but also I got a really delayed flight, so it was terrible, right? And it was 7 p.m. at Dublin Airport. My baggage didn't arrive. And then I was looking at Google Maps, like, how am I gonna get to the castle? And so I was like, okay, and I clicking and clicking. And you take Google Maps, and then you go like, okay, I need to buy a ticket, and then I got to go somewhere else, and then there's nothing quick, there's nothing like could help me solve that easily. And I don't know if you guys saw the recent release from OpenAI, Search GPT. Have you seen it? It's smooth, right? I mean, I didn't need to go anywhere else. And I want to do that today with you today. So I'm gonna walk you through this process of creating a smart search that we have a need, but how can I find the products for my need? And that's my talk today. So how search is evolving and how we can definitely improve our user experience, our own experiences, based on something that also happened to me. But I think this is how we want experiences, how we can improve them. And I hope this is exciting for you too. So yes, I'm Aileen, I'm from Mexico. And yeah, I'm just really, it's my first time here also in NodeConf. I'm really grateful for organizers and you guys being here. It has been an amazing conference so far, and I hope you continue to enjoy it. We still have a lot of talks. Okay, so I want to start with key concepts, just that we have a knowledge base. So what is a model? We're gonna use models today, and I just wanna make sure that everybody knows what's a model. And it's gonna be a very high overview. What I envision a model is basically a black box that has a lot of, has been trained with algorithms, weights, biases that will help us. We're gonna interact with this model. We're gonna provide an input, and that input could be text, video, audio, and then that model has been trained to provide me something, an inference, a result, or an output. And this output could be audio, text, an image. That is basically how we're gonna interact with the models today. It's more complex than that, but I just want to envision how we are going. It's like we use an API. And also, today we're gonna talk about large language models. What are large language models? They're basically models that are very good at understanding and generating human language. They're based on transformer architecture. This is an architecture from a paper called Attention is All You Need. It's back in 2017. If you want to geek around that, it's really interesting paper. And also, they're trained with huge amounts of data. And lastly, they work for many tasks. What this means is like you can summarize things, you can question answer things, and translate, right? They do many things with just one model. But then within the large language models, there are two kinds of models. There's like closed models, which is maybe the ones that you have already interacted with, like Claude Sonnet, Chat GPT-4, Gemini, and Mistral has its own, right? But what's the difference? So a closed model is something that you have access via an API. You get a token, you get it, but it comes with a cost. You're relying on somebody to have that infrastructure and that model available to you. So you cannot download it. You don't know how it was trained. So you're basically relying on those companies to use them, right? And then there's the open source models. And you can find those in Hugging Face, which is basically like the GitHub of AI, where you can find models and data sets. And there's also models that are really, really famous, like Llama or Gemma and Falcon and so on. And all of those, you can find them in Hugging Face. But also, you could run them locally in your computer using a tool called Ollama. So basically, you have a llama, and it provides you with an endpoint that you can have, and you can download the models available in open source. So it's an amazing way to also try them if you want to, because you can actually download them and play around with them. Also, Hugging Face provides like this card, so you know how it was trained. They are very heavy, right? So that's why you need to have maybe an infrastructure, or just, as I mentioned, try them locally if you have like a good computer that you can try them, right? But the good part is you can interact with them and know how they were trained. Okay, so this is just a baseline of some of the things that we're gonna use. And as I mentioned, I want us to build this smart search. And to build this, there's something called RAG, which is, maybe you have heard of it. Have you heard of it? RAG? Amazing. So we're gonna go through this and how we can improve our searches. And this is like the secret sauce of how we're gonna do this smart search or semantic search. And to build this, we're gonna go step by step on this, of each of this, so you can understand how to accomplish them and also using RAG. So, if we want to search for something, we need data. In my case, for this example that I'm going to use, I went into Kaggle. Kaggle, it's another platform that you can find open source data sets and models. So I basically looked for an Amazon data set that was open and available. It's a CSV, so basically that's how it looks. But maybe your data, depending on your industry, might be a database, it could be a PDF, it could be something. So you need data. And in this case, it's just a CSV. There's a dataset link if you later want to try it. And then I have my data, so it's huge amounts of data, right? And we needed to fit that answer or need to our user. It's very different if I just put everything there and then just, okay, give me the answer. It's going to take a long time to go through all of that data. So that's why sometimes it's very important to split that. And what I mean by splitting is doing chunks. So for example, if you have a PDF, you want to do chunks of that data so that when you want to retrieve it back, it's going to be easier to find that. You can use LangChain. It's a tool that can help you doing these chunks and doing the overlap because you don't want to lose context. Or you can just do it manually, right? Depending on what's the data that you're manipulating. In my case, I split it by product, so I have each product in my database, and I'll explain this in a while. So I have my data, and I split it. I have my products, my data, I split it. What's next? So when we want to accomplish something that's a smart search, there's this concept called embedding. And what is an embedding? So basically, we need to transform our chunks of data or our data into something that we would later go and look for, not us, but it's not, we're very used to finding key searches, like I want water, and then you type water, and you go and look for water. But what if I tell you I'm thirsty? How can I retrieve water back? So I need a way to make that query, in this case, I'm thirsty, a context. And in this case, embedding, here is a very simple way. This is just a 2D graph, so it's just X and Y. And there are 3 sentences in here. The first one is the cat chases the mouse. So it's a word, it's a sentence, it's giving context, and it's gonna be put in a coordinate in that 2 dimension. And then there's another sentence, which is the kitten caught the rodent. So it's very similar, it's like synonyms, kitten, rodent. So it's very close. They're saying the same thing, but it's not the same. And then there's the other one. I like ham sandwiches, so it's nothing related to it, so I'm just gonna put it somewhere there. So this is like, we're gonna do this to all of our data, in this case to all of our products. But our embedding models, we're gonna rely on embedding models. That's other type of models that we're gonna use today, that is gonna transform these sentences into a huge array of vectors. And these vectors, it's gonna be depending on the model that you use, so this is a dimension of 1024. This is a 2 dimension, so imagine transforming all of these things in a dimension so that it can map them. So that's basically how we're gonna do this search. we cannot maybe envision that. That's why we use computers for it. But that's how this semantic search works. So we transform our products into vectors, and they're mapped in this dimension. So, OK, that's how it looks in our minds. But in code, how does that look? So I could use Olama. So I have my constant embedding. And I could say if I'm using locally in my environment variables, I could use Olama. And there is this open source embedding model called Nomic. Or I could use OpenAI's embedding model. And depending on what you choose, that would be the option that would be in the embedding. And what I'm doing is I'm declaring here the text to embed. What do I want to embed? In my case, I tried with the name and description, because I want to give enough context so that when I look for that, it understands what it is. So I'm looking for the product name and the product description and stuff like that. And later, I'm just going to put it my product data. I want to store that somewhere, right? I need to store it because later I need to retrieve it. And I transform my embedding, so it's embedding.embed query, and basically just passing the text to embed. OK, I have my embeddings. I did my data, split it, embeddings. What's next? I need to put it somewhere. But where do I put vectors? Because I have vectors. So there is a special type of database. It's called vector databases. In this case, I'm using Supabase. This is an open source tool. It's a backend as a service, and they have a lot of things, but they have PG Vector, which is basically support for vector databases. There's other options like Weaviate, I think Prisma, but it has a free trial, so it's really good. So if you see, this is how my data, my table looks in my Supabase. I have the name, the product name, and then I have the embeddings. And all of those vectors are representing everything that I just put in for each of my products. So this is very good because this is how we're going to do the similarity search. This is how it's going to get accomplished. I'm not going to look for keywords. I'm going to go look for the embeddings. OK, so I got it all out. How do I get it back? I have all my structure. Now I need to look for it and get it back. So there's different kinds of doing this. We could do the keyword, which I believe is the one that we're more related to. We could do semantic or hybrid, which is a mix of the both. But today we're going to talk about semantic. And how are we going to accomplish this? So we first need a question, a query. And then we will need to transform that again into an embedding, because we need to make the embedding match, right? So I have my user input, and then I transform that into an embedding. Then I go look for it in my vector database, and I get it back, right? So how does that look in code? I made an API with Node, which is just a slash search. I have my query. And within Supabase, looking for this, there are two things that I'm interested in. One is the threshold. The threshold is, so there's going to be calculations that it's going to say, it's very similar to it, and I want it to be like 50%. Give me, my minus is 50%. And then I just want, give me 5 back. I just want 5 of those matches back. You can change that according to your needs, but in this case, I just use 50% and just give me 5 back. I got my query. I transformed that again into an embedding, which is the embeddings, the embed query. And then once I have the embedding, depending again if you want to use Olama or if you want to use OpenAI. I'm using, well, in the demo you'll see which one. And then, OK, I transformed it. I have my threshold. And in Supabase, there is a token, and there is a URL that will point to your vector database. But there's also a function. So basically, when it says supabase.rpc, is basically I'm saying there is a function I defined there, which is called match products. And then I'm going to put the query embedding, and then I'm going to say match the threshold, which I defined, which was 50%, and then the limit. And then later, I'll get those back. We can later see the function that I have, but basically that's how we interact with it in our Node code. That match function lives within Supabase, and I just interact with it via the API of Supabase. So I got the results back. Do I just need to show it? Because basically that's what we do with Google, right? You look for something and it gets back. But how can I make the experience better? And do you remember where large language models were good at? Generating human language. So I'm going to use a large language model to provide a very user-friendly answer. I just don't want the answers back. That can be done, but how can I make it friendlier, UX experience better? So I don't need to transform anything anymore because the LLMs are good at understanding human language. So I just need the user input. I just need the context, which is basically what I got back. And I'm going to say, hey, please transform this into something that I'm going to put out for the user. And you could use any of those models. In this case, I use Gemini. So I created a prompt, first of all, and I mentioned, you are a helpful shopping assistant, helping someone find products based on their search. And then I provide a lot of things that I will need back later for my UI. But this is the part where it's got a response await model, and that's where I'm putting the prompt. I'm providing the query in the first part of the prompt, and I'm providing the context, which is all of the products that I got back. And so let's see it in action. So I'm using yes. This is a Next app connected with Node. So this is just products from Amazon. And so I'm not going to search for a product. I'm going to search for a need. So for example, I can say, I want to build, I don't know why I'm using caps, a podcast setup because it's getting popular. So I just want to make a podcast. Why not? So what do I need? Just wait a little. So I created this AI analysis. This is generated all by Gemini. And it's, why do I need it? I mean, because I can get back the products with what do I do with each of those products? I made my prompt so that when I get this back, I'm going to provide an analysis. You'll need this, this, and that because that's how things work. And then I also wanted, like, because this is an CSV, some of the images are not available because they weren't available. But I also want to know the products. And I also, based on the ratings, like, it's going to be a very different experience than just going to Amazon and going like, okay, I need a microphone. I need headset. I need going for each, instead of just going and I want to build this, what do I need? And then you have all of these steps. This is more interactive, of course. There's more code on the UI to provide this. But all of this came from the process that we just built. I'm also at the relevance of it, how matching details I'm using with the similarity search that I'm doing. And I can also add the reviews if I wanted. Like, it's all in one place, and I don't need to go anywhere else. I wish I could have done that when I wanted to come here. And I could try another thing, like, let's say I want to cook breakfast. I'm not saying what breakfast is. I'm not saying anything. It's a need. I want to cook breakfast. What can I get back? And so it's an AI analysis, and I'm getting an egg boiler. I'm getting some sandwich maker. Again, an egg boiler. So it's basically things that I could use. I mean, I didn't look for those. How does it know an egg is for the morning, right? So this is how I think we can definitely provide a better user experience on search. I also want to say that not every app needs AI, but I do know and I do feel that there's a lot of improvements in our current apps that can definitely help us. I mean, I think this is really helpful, and it's improving how search works. If you've used Perplexity, it's the same thing. So this is how our search are getting improved, and I think it's a big market out there that we could definitely go for it. So I hope you enjoyed it. I will push this code later on if you want to try it. Yeah, thank you.
I think we have a little time for questions. You want to take a couple questions? Let me grab the mic real quick. Be right back. And it looks like we have a question from James. Here you are, sir.
Thank you. So first of all, that was probably the clearest explanation I've ever seen of that, so thank you. On the embedding step, you talk about, you have to put the input in and generate an embedding for it. And the part I think I may have missed is how is the embedding generated? What step, what is doing that, generating the embeddings? Like you showed the graph and it's like you could do it manually, I guess, but what is doing it automated?
So in this example, I'm using the OpenAI embedding. So I actually use the input. It's a string, and I just pass in the. Let me show you in code. It's better. But it's basically just the text input to a function that OpenAI already provides to you. I define the model, which is text ADA, is the default one. So basically, it's using that one. So I put the text, and I get that vector back. It's just like a function. It would do it. It's an API interaction, basically.
Okay. So to generate different embeddings, you could do that yourself or use somebody's model.
No, I mean, I'm not sure if you I think you could create an embedding, but I mean, I would rely mostly on on using OpenAI or a model out there. Like there's also a lot of open source embedding models. So the idea is that you either have it downloaded to do that, or you have an API like OpenAI who provides that. I'm not sure if Claude or the other ones have an embedding model, but I'm using the OpenAI embedding model.
Thank you.
Yes.
You said you're going to push the code up. Will you put the presentation anywhere?
Yes, sure.
Okay. Great. Thank you.
Beautiful. Any other questions? Yes. One moment.
Hello, it was a great presentation,
Thank
by
you.
the way. Just one question. Let's say that you have this exact application, but the data could be provided by a user. So it could be kind of trash data. How would you go along with that?
Yeah, so I currently have my data because I own it. Mm-hmm. I cannot control what the user is gonna ask. You can definitely crash any app if you leave it to the user, right? I think it would depend. I have the control of the data, so in this case, I know it's gonna be safe. Mm-hmm. But if you want to provide, because Orama, for example, they give you all the UI. You just provide the PDFs or whatever. So it's more of a responsibility of how do you want it to work. Like to answer your question would be I usually just control my data. I haven't provided a way for the user, but it's definitely doable because you could just upload a PDF and a CSV or whatever and then just make it interactive, and that would be amazing. But yes, you will have that issue of, is the data good? You'll never know. So
would you like maybe create another LLM to make the data better?
I mean, it could be in yesterday's talk of malware, right? So it's like they would scan all of the things. So maybe if there's a process where you could look into things like, you know what this might be, yeah, I think you could definitely use a model that could definitely clean your data and just have it that way. Yeah.
Okay, thank you.
Yeah, no problem.
Thank you. Any other questions? Any questions? Going once? Going twice? Yes, you over there?
I was just wondering, how does it feel to be so awesome?